All right, so a company manufactures two products, A and B, and the profit per unit sold is $3 and $5 respectively. So straight up, oh, you're kidding, come on, Ian. Cool. Why doesn't my pen work? I'll go back to the old battery. So straight away we can write our profit equation for this. Yeah, we've got two things, we'll call them A and B. Here we go, nice. So profit equals 3A plus 5B. That's our first equation. And we've got on our axes, we've got A on the horizontal and B on the vertical. Each product is similar to a particular time. Each unit of product A takes 12 minutes and so we've got a time constraint. We know that 12A plus 25B, how much time have we got altogether? 30 hours. So what's 30 times 60? Is less than or equal to 30 times 60, which is 1800. Okay, so that's another, and we've got another constraint. The company technology constraints mean that for every 5 units of product A produced, at least 2 units must be produced. Okay, so that's tech constraints. So if I have 5, B must be 2, 3, 4, so on. Is that right? And if A is 10, B is 4, 5, 6, and so on. For every 5 units they produced, at least 2 units of product B must be produced. So it looks like B is greater than or equal to 2 times A over 5. Do people agree with that as a constraint equation in relation to the tech constraints? If you're typing in the chat, unfortunately, I can't read it at the moment. Oh, yes, I can. I can flick out of, can I flick out of sharing? Oh, now I've gone and messed it up. Okay, let's color these bad boys and put some lines on. So green will be our time straight there. So I'm going to use that straight line deal that if A is 0, then I know that 25B equals 1800. So B is 1800 divided by 25, which is 72. So when A is 0 across here, B is 72. There's 70, 72 must be about there. And if B is 0, 12A equals 1800. So A equals 1800 divided by 12, which I think is 150. It is. So when B is 0, A is 150. And if I put my ruler on there, come on. There's my straight line. And we know that we want 12A plus 25B to be less than or equal to 1800. So if A was 0 and B was 0, if we were here at the origin, we'd want to keep that. So we're going to shade out the other side. And that is the line 12a plus 25b equals 1800. And I write that line there just so that when I come back to it later on and I'm using it to find my points, I know where it is. Now, my other line, we'll do that in red. My tech line, for every 5 units of A produced, I need at least 2 units of B produced. So I want to plot the line B is greater than or equal to 2.5. So B is greater than or equal to 2/5 of A. So it goes through 0, 0, and it's got a slope of 2/5. So if I go across 50, I go up 20. And the scale here is not quite even, but that there will give me my gradient of 2/5 from that straight line. And I put my ruler on. Come on, ruler. That's close enough. Okay, and if B is greater than or equal to 2/5 A, I want everything above that line. So I get rid of the stuff below. Let's just check. We're doing it, yeah. Okay, so our feasible region is this region in here. Now there's a couple of constraints that haven't been given. Clearly A must be greater than or equal to 0 and B must be greater than or equal to 0. We can't make a negative number of items. So this space around here, we clearly can't have. And that'll give us 3 points we want to consider. And I'm not going to call them A and B this time. So our critical points, I will call them C, D, and E. So point C has the coordinates of 0, 0. Point D has the coordinates we found before that it's B is 72 and A is 0. And point E is where these two lines cross. So we're going to do some simultaneous equations to find point E. So what was the equation of that line? That is B equals 2/5 A. So when I'm finding point E, I'm solving simultaneously the pair of equations B equals 2/5 A and 12A plus 25B equals 1800. I'm going to substitute, use substitution this time. Wherever B is in this equation, I'm going to put 2/5 A. So 12A plus 25 lots of what B is 1800. So 12A plus 25/5 is 5. 5 times 2 is 10. A equals 1800. So 22A equals 1800. A is 1800 over 22, which is 81.81. Or 81.81. And when I look at my graph, 50, 60, 70, 80, it's about there that they're crossing. So that's I'm comfortable with that. Now let's check B at that point. B must be 2/5 of A, which is 2/5 of 81.81. I haven't cleared my calculator, so I've still got all those extra decimal places in there. And 2/5 of that is 32.73 with a bit of rounding. And it looks like it's around 32.73 as well. But what I can do, and if I've got time, I should always do, I'm going to check it in the other equation. And my other equation here is 12a plus 25b equals 1800. So let's check. 12 times 32.73 plus 25 times, oops, I've made a mistake there. I've put B there where I should have A, sorry. 12 times 81.81 plus 25 times 32.73 is 12 times 81.81 plus 25 times 32.73, which is 1799.7. So that's the correct point. So I've now found my three critical points, 81.81 and 32.73. The company has been offered a chance to hire an extra machine, thereby doubling the effective assembly time available. What is the maximum amount the company should pay for this new machine and why? Well, before doubling the time, I'm going to find the profit at these 3 points. Okay, and my profit equation is 3a plus 5b. So let's work out our profit. At point C, it's going to be 3 times 0 plus 5 times 0, which is 0. So, yeah, there's no point making no products. At point D, it's going to be 3 for every A plus 5 for the 72 Bs, which is 360. And at point E, we're going to get $3 profit for each of the A's plus $5 profit for each of the B's. Now, per unit sold respectively, price similar to each per unit price. So I probably should be rounding these or looking for a point that's inside the space, but for now I'll work with it without, and we'll come back to looking at it with integer points soon. So the profit at point D is $409.08. So I have a new constraint equation coming in here. Where's my pen? I don't know. Let's go with purple. So my new constraint equation for time is now, it still takes the same amount of time to make an A and a B. It still takes 12 minutes to make an A and 25 minutes to make a B. But I've doubled the amount of time available. So instead of it being 1800, it's now going to be 3600. And what that will do is that'll move this green line here out to a new line. It'll be somewhere out here. 12A plus 25B equals 3600. If I can find this new point here and work out its profit, the change in the profit will be how much I should pay, because I don't want to make less money than before. I don't want to have to pay more for the extra time than I actually get out of the extra time. So let's find the new E. So we know that B equals 2/5 A, and we know that 12A plus 25B equals 3600. Again, doing the same stuff as before, I'm going to get B. I'm going to get 22A equals 3600. So A, instead of being 8181, is going to be 163.63, just doubling that. And B will also be doubled as well. So instead of being 3273, it'll be now 6547, something like that. So the profit at new E equals, what did I get? I got, it'll be 3 times 163.63 plus 5 times 65.47, which is twice what it was before. It'll be $818.16. So the most I should pay is, or it's got to be the new profit minus the old profit. Whoops, old profit, which is 818.16 minus 409.08, which is 409.08. And that's just, the reason that that's just doubled is because of the shape of our feasible region has now changed. We just moved out to twice as far, and because we were able to double the effective time. But you can hopefully appreciate that if, oops, a daisy, if we had a different, instead of just doubling the time, it might be we're now able to have 2,000 minutes available instead of 3,600 minutes available. So the final thing I think it's worth covering off here is those integer points. And let's think about that point E, the original one. Just the original point E was the point 81.81.32.73. Clearly, we can't make exactly 81.81, and we can't make 32.73 points either. Is there some way I can get a grid? Beauty. Let's have a look at that. So let's think about the point E. If I make this across here, 81, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 82. And going up this way, if I make this here the point 32, 1, 2, 3, 4, 5, 6, 7, 8. Oh, bollocks. Sorry, if I make that 32 down there. So that point, this one here, is exactly 32.81. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hey, John T, I'm in a class, mate. No, no one's hiding in here. Just got one of my year 9s who's in the in-school bubble come and he stuck his head in. So this point 81.81 is about there, and 32.73 is about there. So here's my point. That's the solution I found. And what we want to do is we want to look at all the whole number solutions around that point and see which one of those 4 crosses, and I'll number them. That's point 1, that's point 2, that's point 3, and that's point 4. Which ones of those are inside the feasible region, and of those, which is the maximum? Okay, because we've got these 2 lines coming through. One's coming through a bit like this, isn't it? That was, oh, that was our green line. Let's make that green. That was our green line coming through there. Yep. And we'd shaded away above that. So point 3 we can't have. And the other line we had was our red line. And it was coming through there something like this, wasn't it? From memory. And we can't have below that. So it looks like we can't have 3 and 4. Maybe we can have 1, and I'll check whether we can have 1, but we can definitely have point 2. We can definitely have the point 81.33. I'm going to check if I can have 8132? 8132. Can I have that? So our two constraints were B is greater than or equal to 2/5 A. That was the red one that I wanted to check on. It definitely fits the green one. It definitely fits the green, but does it fit the red? Is 32 bigger than or equal to 2/5 of 81? 2/5 of 81 is 32.4, and that is not. So 32 is not greater than or equal to 32.4. So I can't have that point either. This is the only point I can have, this one here, if I wanted to do integer solutions. So with integer solutions, the maximum profit, got the same profit equation again, 3A plus 5B, 3 times 81 plus 5 times 33. 5 times 33, $408. Okay, it's slightly different to the 409 we had before because we've come back to the left, but we've actually been able to go up slightly. Now, the final thing that's worth looking at is the moving line approach. The profit is 3A plus 5B. B is on my y-axis, so I want to rearrange. 5B equals minus 3A plus the profit. So B is minus 3/5 A plus profit over 5. This here is the gradient of my profit line. It's minus 3/5. So anywhere on here, if I go down 3 and across 5, that's my gradient. And if I grab my ruler again, there's my profit line there at that minus 3/5 gradient. So if I take that minus 3/5 gradient and I go back to here, okay, we can see where that maximum is. If I go back up to where we started and try and get a bit bigger, again at that minus 3/5, and let's do it on here. Now we've just got to be careful because the scale is different here. So 30, 50, that's a 3/5 gradient. Okay, there we can see as that line moves up and out, it leaves here. There's my maximum, there's my profit line. And with the moving line approach, I keep it up on that same gradient. I've moved it up and out, and it leaves there. So my moving line approach confirms that E is the maximum profit. It doesn't tell me what it is. It just tells me that that's where it is because my profit line function with that gradient of minus 3/5, when I move up and out, it leaves at point E.